Good morning, geometry students. This is Mrs. LeGroux, and this video is on special right triangles, specific case 30, 60, 90 triangle. And the ratios that we're going to be using for this specific triangle are these. Our 30 is going to represent the short leg, the 60 will represent the long leg, and then across from the 90 will represent the hypotenuse. Okay, and so what I mean by that is that the side that's directly across from the 30 is labeled X, and the side that's directly across from the 60 will be labeled X square root of 3. And then the third side directly across from the 90 will be labeled 2x. And we will use this to find the values of the missing sides in this type of right triangle. Okay, also this type of triangle happens to be a scaling right triangle that has different measurements for each of the three side lengths. Okay, so let's take a look at the first example. Here we notice that this is a 30, 60, 90. It's missing the 60 in the picture, but we can go ahead and add it up here. And we also can see that directly across from the 30, the side length is labeled 2, which means that in this picture, our x is equal to 2. And so we'll go ahead and we'll write 2 up here. And then since this is our short leg, we go ahead and we use the value of 2 to go ahead and find the value of the long leg and the hypotenuse. Now, this type of example is pretty simple because all we're going to do is end up multiplying. So here for the 60, we will multiply 2 times square root of 3. And then to get our hypotenuse, we will multiply 2 times 2, which will give us the value of 4. So what this means is that our hypotenuse has a value of 4 and our long leg has a value of 2 square root of 3. So the answers to this problem would be u equals 4 and v equals 2 square root of 3. Now for those of you guys who don't like just to have an answer and you want to double check to see if this is accurate, there is a form of checking. Since this is a right triangle, we can use the Pythagorean theorem in this case. Now, just remember that the longest side is the hypotenuse, which is the c in the Pythagorean theorem. So when we substitute this, we will do it as so 2 squared plus 2 square root of 3 squared equal to 4 squared. And then we just simplify. 2 squared will give us 4 plus 2 squared times 3 equals 16. And then simplify 2 squared times 3. So that would be 4 plus 4 times 3 equals 12. And then bring down your 4. Multiply 4 times 3, which is 12, equal to 16. And add those 4 plus 12, which is 16. And guess what? Yeah, we did that correctly. The values that we found using the ratios were correct. So for sure, these two are correct, okay? In the next examples, I'm just going to be solving for the missing sides. I will not be checking each one. Okay, so here is a different example. And this time, they've given us the value of the hypotenuse, and I know that because it's directly across from the 90-degree angle. So in our ratios here, that means that we have the value that is equal to the 2x. So we're going to have 2x equal to 16. Now, if you notice, this looks like a equation, right? So what we're going to end up doing is we're going to solve 2x equal to 16. Now, we're going to divide both sides by 2, and we end up getting the value of 8, okay? So what this means is that our short leg for this triangle has a value of 8. So in the short leg, I'm going to label that 8. So across from the 30-degree angle, now I don't see the 30-degree angle here, but because it's missing in this place, in this spot here, that would give you the value of the y. The y is equal to 8 in this triangle. Now, to get the long leg, because we already have the short leg, it's very simple. We're just going to plug in the 8 where you see the x, and then we're going to multiply that by square root of 3. So the value of our long leg is 8 square root of 3. And so the answers to this problem are x equals 8 square root of 3 and y equals to 8. Okay, now you could plug that into the Pythagorean theorem to double check, but you can do that on your own. Okay, let's try a different example. All right, so this time I have given you the value that's directly across from the 60, which means that we're going to go here and set x square root of 3 equal to 5 square root of 3. Now, because we have to isolate the x, we're going to set up our equation, and the relationship between the x and the square root of 3 is multiplication. So we're going to undo that multiplication by dividing by square root of 3 to both sides. So let's do that. This will cancel out this or simplify the square roots on the left, which gives us x. And then on the right, we will also simplify the square root of 3's there, and it will just give us 5. What this means is that our short leg has a value of 5. So we're going to go ahead and put that here. Now you could say, couldn't we have seen that just by looking at this? Yes, you could have. But I just wanted to show you how to get that mathematically. Okay, since we have the short leg, it's going to make it easy to find the hypotenuse. All we're going to have to do is substitute the 5 into the x. So it would be 2 times 5, which gives us a value of 10. So in this case, the hypotenuse is going to give you 10. So we're going to label that 10. And then our short leg was 5, so we're going to plug that in. So for this triangle, the x is equal to 10 and the y is equal to 5.